Hey, what's going on, guys? I hope everything's going well in your math lessons. Today, we're doing lesson 9.4, which is graphing linear functions. Now, a linear function is a function that is written as an equation with an x and y variable that are both to the first power, so there's no exponents. And what's special about this function is that after we graph points on the line, we are actually going to be graphing this as a line. We're going to be connecting the dots and graphing this as a line. So with that being said, let's go ahead and dive into some examples and so we can fully understand the concept of this lesson. So before we start graphing lines and everything like that, we first need to understand that it is impossible to list all of the possible ordered pairs that could be graphed on a single line. Now, a linear equation is going to look something like this, and this is actually in slope-intercept form, and we're going to learn about that later on in the chapter. There's also another form called standard form that looks a little bit different, but even if it's in standard form, we're going to turn it into slope-intercept form. So we're just going to leave that equation like that. So a lot of times, and what's going to be asked in this first couple of examples is it's going to ask, is a certain point a solution for this linear equation? And so the way that we would have to solve that is we're going to insert the x and y coordinate where we see x and y in this equation, like this. Let's take our equation of y equals 2x plus 3. And then let's look at our ordered pair. Let's remember that the first number is the x and the second number is the y. Meaning that we're going to use these numbers with these ordered pairs to fill in this equation. So for this problem, y is going to equal 2 because 2 is our second coordinate, 2 is our y coordinate. So we're going to put 2 equals, and then we're going to fill out the rest of this equation using -1 for x. 2 times, or 2 equals 2 times -1 plus 3. Now we're going to solve the right side of this equation. 2 equals 2 times -1 would be -2. -2 plus 3 is +1. 2 equals 1. Is this a true statement? No, it is not a true statement. Meaning that the point -1, 2 is not a solution. Meaning that when we graph the line y equals 2x plus 3, the point -1, 2 will not be on that line. Let's look at example 2 really quick. All right, example 2 is point 27 a solution for the same equation that we just used, y equals 2x plus 3. So we're going to do this the same exact way we did example 1. We're going to take our equation y equals 2x plus 3. And then we're going to ask ourselves, with this point, what does y represent? And in this point, y is 7. Okay, so we're going to put 7 equals 2 times. Now we're going to ask ourselves, in this problem with this ordered pair, what does x represent? And x represents 2, or 2 represents x. So we're going to put a 2 down here plus 3. Now we're going to solve the right side of the equation to see if we get a true statement or not. So this gives me 7 equals 2 times 2 would be 4 plus 3 is 7. 7 equals 7, which is a true statement, meaning that yes, point 27 is a solution. Let's do another example to introduce a little bit more stuff. Before we do example 4 and before we start graphing lines and plotting points on the graph and everything like that, I want to go over a couple of things, or at least one major thing about linear equations or graphing lines on a coordinate plane. Now, in order to graph a line on a coordinate plane, you have to have at least 2 different points on that line. Now for today's lesson, I'm going to require you to have 3 different points, but sometimes there's not any x coordinates given. Kind of like in example 3 here. In example 3, it says find 3 ordered pairs using the equation f of x equals x minus 4. Now, in my opinion, I like it when it doesn't give us x coordinates, because the great thing about these functions in coordinate planes and stuff like that is that if it doesn't give us x coordinates, we can make up our own x coordinates. As long as we use this formula correctly, we're gonna get the right y coordinates. So when we have stuff like this, example 3 says, find 3 ordered pairs using this formula. We're gonna set up a table like we've been doing, and then we're simply going to pick whatever 3 x coordinates we're gonna do. So let's set up our table. We have f of x, our formula, x minus 4, and then our y coordinate. So because we get to pick whatever x coordinates that we want, let's make it easy on ourselves, okay? Sometimes the book has all these different numbers, but I'm okay with, my first choice is always 0, okay? And there's a reason for that later on, but anything, if we can put 0, then we're gonna be doing easy math anyways. So my first point is going to be 0. Now I don't have my book right here on me, so I don't know exactly what numbers they use. If you want to use the numbers they use, great. But I'm just going to use 0. I'm going to use 1 because I know that's easy multiplication and easy subtraction. And then I'm going to use 4 because I know that I'm going to be minusing. So again, I'm just trying to make my life a lot easier, so I'm not having to do any kind of extra addition or subtraction or anything like that. So let's now that we have our 3x coordinates, because we need at least 3, let's find out what our y coordinates are. So when x is 0, and we throw it in this formula, this is going to be 0 minus 4, which would be negative 4. Next, we have the x coordinate of 1, so we're going to plug in our table. Sorry, I was doing that wrong. 1 minus 4 to get negative 3. And then last, we're going to be doing 4. So when x is 4, 4 minus 4, y equals 0. So now we just have to make these 3 ordered pairs, and then we're done. So this is going to be when x is 0, y is 4. Negative 4, sorry. When x is 1, y is negative 3. And when x is 4, y is 0. And that's it. That wraps up example 3, and that's how we find 3 ordered pairs using our own x coordinates and the equation they gave us. Let's do another example, and I believe in the next example we're going to start graphing lines on the coordinate plane. All right, example 4 says graph the linear equation y equals x plus 2. And before we can graph and before we can dot any points on a graph or anything like that, we first have to come up with 3 ordered pairs. Again, you need at least 2 in order to graph a line, but on today's lesson, we're going to use 3 different points, just so the more points we have, the more accurate our line is going to be. So the way that we're going to come up with these 3 ordered pairs is just like we did in the last example. We're going to make a table. So we have x plus 2, and then y. And then we can pick whichever x coordinates we want. You can pick any positive or negative number you want. Just remember, the bigger the number that you pick is the further out you're going to have to graph on this coordinate plane. So if you have a small coordinate plane that you've printed off, you might not want to use 23 for your x coordinate, because then your x is 23 and then your y is going to be 25. So you're going to be counting a lot of lines and you might not have enough space. So just remember, keep them a little smaller. Don't get too crazy. So for my x coordinates, I'm going to use 2. I'm going to use 0, and I'm going to use negative 2. I don't know which ones the book used. I don't have my book with me right now, but these seem like good numbers because of that 2 right there. Now that I've done this, I'm just going to fill out the rest of my table. So when x equals 2, I'm going to put a 2 where this x is, 2 plus 2. When x equals 2, y is going to equal 4. Now I'm going to move on to the second one. When x is 0, so this is going to be 0 plus 2. When x equals 0, y is going to equal 2. Now we're going to move on to the last one, where we have negative 2 plus 2, x equals negative 2. So when x equals negative 2 plus 2 is 0. When x equals negative 2, y equals 0. Now that we have done this, and let's write out our ordered pairs. This first one is going to be when x is 2, y is 4. When x is 0, y is 2. And when x is negative 2, y is 0. Now that we have our ordered pairs, we're going to go to the graph and we're going to graph our points and then draw our line. All right, here are our 3 points that we got from our graph or from our table over in example 4. And so now the first thing we're going to do is we're going to go ahead and plot these points on the graph, just like we've done in previous examples. So the first point, 2, 4. We're going to start our origin, go over 2, and then up 4, and connect that, and then put a dot there. Next we have 0, 2. Remember, 0 meaning that we're not moving left or right anywhere, but then we're going up 2, 0, 2. And then next is negative 2, 0. So we're going to move over to the left 2 spaces. We're not moving up or down because of that 0. And we're plotting our point there. Notice that all 3 of these dots are creating a straight line. So in order to draw our line, we simply just have to connect the dots and draw a line. Now, disclaimer, my line's probably not going to be straight because I never can draw a straight line. If you want to use a ruler or some kind of straight edge, you're more than welcome to do so. So this line represents the equation y equals x plus 2. And this is how you graph a linear equation. Now let's talk about really quick what if one of our points when we did our table was like down here, okay? We decided to do a 4th point, we did our math way wrong, and our point's right here. Obviously that is not connected to this line, so please don't try to connect and like make a weird turn like this. That is not how we graph linear equations. If you get an answer where the dot is way off base, then go back to your table and see if you can figure out what you did wrong. All right, let's do our last example for this section and then you can start on your assignment. So example 5 is graph the linear equation f of x equals negative 2x minus 5. And again, we're gonna do this just like we did example 4 by creating a table. So we have x, negative 2x minus 5, and we have y. And again, we get to pick any 3 x coordinates we want because they did not give us any kind of list to use or anything like that. So we get to pick any ones we want. The first one I'm going to do is 0. Since we have something times x, I'm going to use 0 so that way I can do easy math. And then I'm even going to double and triple down on the easiness, and I'm just going to do 1 and negative 1. Yes, you are allowed to do that. This is not cheating. This is just making everybody's life a lot easier. So I've picked out my x coordinates. Now I have to fill out the rest of my table. X equals 0 in this first column, so I'm going to have negative 2 times 0 minus 5. Negative 2 times 0 is 0. 0 minus 5 is negative 5. Next column, x equals 1, so I'm going to have negative 2 times 1 minus 5. Negative 2 times 1 is negative 2. Negative 2 minus 5 is going to be negative 7. And our last column is x equals negative 1. So we have negative 2 times negative 1 minus 5. Negative 2 times negative 1 is positive 2. Positive 2 minus 5 is going to be negative 3. Now I need to list out my ordered pairs. I have 0, negative 5. I have 1, negative 7. And I have negative 1, negative 3. Now that I have figured out my 3 ordered pairs, let's go to the graph and we'll graph those points and graph our line. All right, here are my 3 points that I got from example 5. And the first thing we do, just like we did in the last example, is we have to graph these 3 points. So let's start with 0, -5. That first coordinate of 0 tells me I'm not moving left or right any at all, but I am going down to -5. Next we have 1, -7, meaning we're starting at the origin, moving over to the right 1, and then down to -7, or down 7 spots. And then the last ordered pair, we're starting at 0, moving over to -1, and then moving down 3 spots, 1, 2, 3. Notice that these points are in a straight line, so to graph this linear equation, we are going to connect the dots. Again, if they're not a straight line, mine's not going to be a straight line, don't judge. If yours isn't a straight line, that's okay, as long as it's straight-ish. If you want to use a ruler or any kind of straight edge, you're more than welcome to do that. So connect the dots, very squiggly, but that's fine. And these 3 points are graphing the equation f of x equals -2x minus 5. And that's it. That wraps up example 5. Good job. All right, that's going to do it for today's lesson. I hope you fully understood everything that we were going over today. If not, that's okay. Please feel free to reach out to me. If you don't already have my contact information, your parents should, so go ahead and get that from them. And if I can't help you out either over the phone or through text or FaceTime or anything like that, and you want to meet up here at the school one-on-one, that's fine with me. Just have your parents contact me first and make an appointment so that way we're here at the same time. I wish you good luck on your lesson, and I'll see you next time.